Okay, we're in chapter 3.5 today. We're going to be showing lines parallel. All right. So what we're going to do today is basically the reverse of what we were doing in chapter 3.4. Chapter 3.4, we were investigating what took place when you had two lines that you're told are parallel. When that happens, you have certain relationships that come into play with these angle pairs. Corresponding angles, we were told, we see now, based on postulate 8, they're congruent. Alternate interior and exterior angles, congruent. Same side interior and exterior angles are supplementary. So now what we're going to do in this next section here is, let's say you're going to be given a set of lines that you don't know for sure are parallel. All right? You don't know that they're parallel, but you know that, let's say, corresponding angles are congruent. If you know that to be true, then you can go ahead and conclude the lines are parallel. So what we're going to be doing is using these angle relationships to demonstrate lines are parallel. If I have two lines cut by transversal and alternate interior angles are congruent, then that means the lines must be parallel, because that's the only time that that's going to happen. So we're just taking what we learned in 3.4 and we're running this in reverse now. Okay, now in discussing this issue of showing lines are parallel, let's first talk about what is meant by the converse of the statement. Okay, the converse, when we're talking about the converse of an if-then statement, that is the statement that is formed by switching the hypothesis and the conclusion. Now, when you do that, your new statement may or may not be true. For example, this example in your book: if you live in Sacramento, then you live in California. Okay, that's true, isn't it? If you switch it around, if you live in California, then you live in Sacramento. What does it take to prove the converse wrong? One counterexample. Okay, just one example. Maybe you live in Los Angeles. Maybe you live anywhere else, right? So the converse is not true here, not all the time. Sometimes they are true. Example 6, or not example 6, but number 6 is one of the problems in your text that you'll be doing for homework. What you have to do is you take the statement that's given to you in the text in these set of problems, switch the hypothesis and the conclusion around, and then make a determine whether or not the converse is true. So if two lines never intersect in a plane, then the lines are parallel. Switch it around. If two lines are parallel, then the two lines never intersect in a plane. That one's true. But not all of these in problems 6 through 9 in your homework are going to be. When you switch them around, you just have to, all you have to do is think of one counterexample that would make the converse statement false, and it falls apart. Okay? It just takes one. Okay? So, okay, now postulate 8 said that if two parallel lines are cut by transversal, then the corresponding angles are congruent. Postulate 9 just switches it around. I gave sort of an abbreviated definition from what you see postulate 9 is in the book. We know we're talking about lines and transversals here. So if corresponding angles are congruent, then the lines are parallel. All right, so it works both ways. And what you'll find here is this: in these example problems, like in example 2 on page 137, is enough information given to conclude that the two lines in question are parallel. Well, you know, and number A under example 2, right? Example 2, letter A, you've got two lines basically running, something like that. You've got your transversal coming down here, and then what you've got are your two angles, 110 degrees here and 110 degrees here. Is there enough information there to determine if the lines are parallel? Yeah, because these angles are corresponding. So yes, those lines are parallel. This is the kind of thing that you're going to be doing. You'll be given some diagrams. Maybe you'll be given a set of alternate interior angles. If they're not congruent, the lines aren't parallel. All right? So if you can do section 3.4, you can do 3.5. They're just learning those in reverse, okay? the alternate interior angles converse. Theorem 3.8 says that if the alternate interior angles are congruent, so theorem, this is the alternate interior angles converse. Okay, simply says that if the alternate interior angles are congruent, the lines are parallel. So that's what all of these do. You know, same side interior angles converse, 3.10. 3.9 is the alternate exterior angles converse. Works just like the alternate interior angle. Theorem 3.10. And then your notes, when you're getting your notes ready, like I said, I'm going to use the list of terms, definitions, theorem. Put 8, 9, and 10 in your notes, okay? Put 8, 9, and 10 in your notes. The theorem 3.10, same side interior angles converse. Okay? That simply says that if same side interior angles are supplementary, meaning they add up to 180, then the lines are parallel. Yeah, we are going to cover two sections today. Do remember, I put your assignment here at the top of this right in here, page 139 to 141, 1 through 32. That's going to be the assignment in this section. We're going to move into 3.6 now. Okay? Okay. Okay, in chapter 3.6, we're using perpendicular and parallel lines. We will be doing constructions later this week, but today I want to just get through some of the basic information in this section of the book that I want us to become familiar with. But I do want to say this about a construction. What is a construction? A construction, and this is in the text. Construction. A geometric drawing using primarily a compass and a straight edge. There's other tools that you could use, but that's what we're doing in here. Straight edge, like a ruler, you know, something like that, all right? So construction, geometric drawing that uses a limited set of tools, usually a compass and a straight edge, a ruler without marks, a ruler with marks, and a straight edge, okay? Side of your book is straight enough, and doesn't have to be bent edges and stuff on it. Can be sufficient as far as that goes. I want you to include postulates 10 and 11 in your notes. Postulate 10 is the parallel postulate, and postulate 11 is the perpendicular postulate. And the parallel postulate just simply says there's a point not on the line. There's one line anyway. I'm sorry. There is exactly one line that can be drawn through that point parallel to the given line. So an example. So I want you to write that definition down. It's in your book, but I just want to write the example of what that means. Let's say you got a line here, right? And here's a point not on the line. There is exactly one line that I can draw through that point parallel to the given line. All right, just one. And that is all this postulate is telling me. So, and by the way, what do we mean by postulate versus theorem? Yeah, right. So a postulate is accepted as true without proof, and theorem you have to have proof. So I'll keep that distinction here. So the perpendicular postulate says this: you've got some line, some point not on the line. It says that through that point I can draw exactly one perpendicular to the line. So through this point, there's exactly one line I can draw through it that's perpendicular to my given line here, okay?
Okay, now the next two theorems that I want to add to your list, you got postulate 10, postulate 11, theorem 3.11 and 3.12.
I'm going to want us to prove theorem 3.12. 3.11 says that if two lines are parallel to the same line, that stands to reason they're going to be parallel to each other, right? 3.12 says that if two lines are perpendicular to the same line, then they are parallel to each other.
And conceptually, let's just think about that for just a moment here. You've got, excuse me, you've got two lines here, okay? I'm going to draw a line perpendicular to both of them. Drawing a little bit different than what, here's a little bit different than what they have in both, they're the same idea. But if I do this, I've got a right angle here and a right angle here. Can you see why those two lines would have to be parallel? So I've got the two lines are perpendicular. Both of these are perpendicular to the same line. They've got to be parallel to each other. Right? So I want us to construct a two-column proof in regards to this. Okay. Okay. I want y'all to get this down. Okay. Theorem 3.12. I went ahead and proved it here. It's not in your book. Given line M is parallel to line P, and line N is perpendicular to P, and N is perpendicular to P, we need to prove that line M is parallel to line N. So, look, our given statement and our proved statement, our list of statements and reasons. So I did this one to you, for you. So this is a happy day, right? I didn't send you home to do this. So what do we want to begin with? Our two-column proof with our statements and our reasons. We begin with the given statement, M perpendicular to P, N perpendicular to P. The justification for that, as you can see, what's given to you. Angle 1 and angle 2, the next statement that states officially, and we're being very methodical, don't want to cut any corners here, angle 1 and angle 2 are right angles. And how do we know that they're right angles? I know you see it in the diagram. But it's technically we need to make a statement involving that. The definition of perpendicular lines would be our justification. One line is perpendicular, okay, you get right angles. The measure of angle 1 is equal to 90, the measure of angle 2 is equal to 90 degrees. That is definition of right angles. So what I'm trying to do here before I continue on, I've got these two lines. If I can establish the congruence of angle 1 and angle 2, I think you can see intuitively that that's true. And that's the first step before you start making the two-column proof. Is look at what's given to you, see what you've got to prove, look at the diagram, can you intuitively see the truth of it, and then start to methodically go through step-by-step the process to spell that out. But these are corresponding angles here. And if I can prove their congruence based on postulate 9, I can prove or make a statement saying that these two lines are parallel. And so that's what I'm trying to go about proving. So the first thing after the given statement, I'm stating that the two angles are right angles, definition of perpendicular lines, which naturally leads to, well, they're both equal to 90 degrees, definition of right angles, which now says I can set them equal to each other by substitution, right? I'm substituting, let's say, 90 degrees for the measure of angle 2 here. So I'm making this substitution. You know, I'm putting 92 degrees in, or measure of angle 2 for 90 degrees, and that's where I am getting this statement right here. Now, angles with equal measure are congruent. That is number 5, and now I can finally conclude 6 steps to do this. Okay? The two lines are parallel because of postulate 9. If the corresponding angles are congruent, the lines are parallel. All right, let me back this up so that you can see all those statements and reasons and get those in. Okay, Ricky, say that again.
When you're looking at two-column proof, how would you go about finding the statements?
How would you go about finding the statements? It's like I've told you before, it takes practice. Initially, I know when you look at this, you're going, man, this is Greek. But I saw what you did in some of your work there. It starts with doing like what I saw you do with the two-column proof you did. We're going to make some adjustments and corrections to it. But that's where you start. And trying to get a handle on this, it definitely takes practice on learning how to methodically think through this. Okay? And no, you don't have to get on math crack to be able to do this. Okay? But it does take practice to be able to get to where you can start to put these things together. But I understand your question, the answer, it comes through practice. I don't know of any other magic formula, it just comes through knowing the definitions, knowing the theorems, knowing the postulates, and being able to break down into the minutia, because that's what this is. Every little teensy weensy step of the way to go from here to here. It helps. Okay, this is theorem 3.7, your proof from last night. Thank you. Let's think through logically what we have to do here before we construct the two column proof, the statements and the reasons. All right, so we've got our diagram here. I've numbered the angles. We want to prove that angles 3 and 5 are supplementary. Now we know from the corresponding angles postulate that 1 and 5 are going to be congruent. We know from a linear pair of angles theorem that we did in the last chapter that 1 and 3 are going to be supplementary. Okay, and so now I can substitute angle 3 for angle 1 in that thinking process to state angles 3 and 5 now have to equal 180 degrees, which then makes them supplementary. Okay, and probably what I should have precisely said here, measure or angle 3 and angle 5 are supplementary angles. That's really what I should have said. Angle 3 and angle 5 are supplementary. Okay, this is basically what the proof should look like, okay? J parallel to K and transversal T, that's not a line, that's a T with an underline under it. One gets erased, that's obvious. That's given, okay? Now I want to state that angle 1 is congruent to angle 5. That's true because of corresponding angle postulate number 8. I went ahead and I almost skipped this step, kind of squeezed it in between 2 and 4. Step 3, measure, since the angles are congruent, measure of angle 1 will equal to the measure of angle 5. Why? Because congruent angles have equal measures. Now I'm going to state that angle 1, measure of angle 1 plus the measure of angle 3 is 180 degrees. We know that because of the definition of a linear pairs of angles, okay, or supplementary. You can just say definition of a linear pair of angles. Now, measure of angle 3 plus the measure of angle 5 is 180 by substitution. And angle 3 and 5 are now supplementary. Line definition of supplementary angles is equal to 180. So that is meticulous minutia that we would go through. And
What is your opinion on that?
on this,
Yeah.
it is very precise. Okay? And that's how I'll state it here. So that's our assignment on pages 147, 148, 1 through 21. Okay? That was your other assignment. Okay? All right, that's going to conclude this.